Okay, let's start the second lecture on industrial robotics. Now, I will not cover the full lecture today, just partially, then we'll carry on next week, and you'll start with lecture 3 next week as well. Okay, I will post up some tutorial questions, I'll hand out some questions as well, we'll do a lot of in-class activities as well. Okay, so whenever I start with this lecture, I will again show these videos. That's why lecture 1 and 2 are full of videos, but I hope you can start to appreciate what's going on when you see these videos. It's not for fun. Okay? Now when you watch this video, okay, at the end of this video we will have a discussion. Okay? So when you are watching these videos, I want you all to take note of the type of, so this video will be more of a workshop floor, things that are happening there with the robot. So I want you all to think about the key issues and challenges that you will face when you have a robot beside you working in the shop floor. Okay? This is what we will be discussing after the video. Alright? Try to think about the possible solutions that you can have to these problems when you have a robot with you, and also focus on the application that they are using.
This is Tom, and this is his colleague Michael. They work for a small company producing small batches of parts and materials of all kinds, and finally assembling them. Welding, chamfering, drilling, sawing, grinding, polishing, knotting are all parts
Guys,
of
can
it.
we listen to the video?
We have to finish this job by Friday. We're going to need some help.
You're so right. Hey, it'd be great if we could get a robot
Please
to help
pardon
us.
the mismatch in the video and the
Robot.
voice.
Yeah. Sure.
Well, why not? We could have some sort of industrial robot. Look at the automotive industry. I mean, they've got loads of robots that do all sorts of jobs, haven't they?
Well, yes. But they can only do what they were built for. Here we have to process different parts all the time. So who's going to program this robot again and again? Not me. I don't feel like sitting at a keyboard half the week until something finally happens.
Look, don't worry. Programming a robot can be a lot easier than you think. We could just show the robot what it's supposed to do. Listen, imagine this is our workpiece, and this is our robot.
Okay. It's insensitive, it's deaf, dumb, and blind.
Yes, but it moves with great precision. Now, if it's supposed to drill holes in, I just show it the positions, starting here, 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 and finishing here. The robot remembers the coordinates and repeats the procedure, and that's it.
Whoa, that thing is dangerous. It belongs behind a fence.
Not if it's equipped with an anti-collision system. Huh? And if we give it a soft reaction to touch, besides making it lighter, it wouldn't do any harm even if it did crash into something or someone.
Not bad. So you could actually work safely in the same workspace as the robot.
Right. And because the robot is now so light, you could easily move it from one location to another.
Wow. So, you could just actually carry it across to the shop floor and train it to other machines. Ah, but wait a second. But for detecting complex parts, this isn't precise enough.
Well, to simplify the programming, the robot could be equipped with a camera or a 3D sensor, so that it could detect the exact positions of the workpieces and choose the best one to grid out.
Yes, yes, of course. And then it might even understand spoken orders.
And why not? Place pump case in workpiece carrier.
with you two? There's work waiting to be done. And what's that thing over there?
We are just inventing a robot to do routine work.
And it's extremely easy to teach. And,
I bet it costs a fortune.
well, no, not really. It wouldn't cost any more than a milling machine. And you needn't buy it immediately. Perhaps you could just rent it for a certain period of time or a certain production quantity.
Sounds all right, but don't you have to have special training to operate it, which also costs?
Well, yes, of course, the staff will still need training, but no more than for any other new machine.
Yes, but
You know what? I think we need to send the management on a training course to show them the advantages of the robot.
okay. So, what are the benefits? Is it versatile?
Absolutely. Just plug in and produce.
For handling? Working different materials? Assembling? Feeding machines? But it can't be used for drilling, milling or grinding.
I think you've got to see it as a multi-purpose tool where you decide what application to use it for.
She's right. For grinding, we might need a different type of robot. One that is capable of applying high forces with high precision.
And it's still got to be lightweight, with collision detection and all that.
Right. What about a robot that's made of rigid, lightweight modules? That might be the answer.
That's a robot too.
Yes, it is. It may look a bit unusual, but these variable parallel kinematics provides the stiffness and high forces required for applications like grinding.
But grinding has to be absolutely accurate. How do you intend to manage the programming?
Well, actually, that's quite easy. Either by demonstration, or if we need to be more accurate, we could feed the robot directly with the CAD data. And then, to check the exact positioning, we just move the tool to a number of reference points. The robot then compares the CAD data with the real object, and automatically generates the program that's needed.
Well, someone really should invent such versatile robots.
The leading European research institutes and robot manufacturers have formed a consortium to develop a completely new generation of robot systems specially designed to meet the needs of small and medium-sized enterprises.
So what were the applications that this robot was doing? Okay, this is an imaginary robot. These guys were just having coffee talk. Right? All this was the imagination that they had. But what were they doing? They were doing assembly, even drilling, right? Thing and place. But when it comes to drilling, what was the major concern of the work? Precision, right? So you realize when the guy, from that one arm manipulator, apparently transformed into one with three so-called linear guides, right? Now that is another type of robot called parallel robot. Okay, I will go through that in lecture 2 as well. So the first one that you saw was a serial robotic arm, something like a human arm. Now the second one was having parallel so-called links connected to a common object. Right? It's something like you have both of your hands and you're carrying an object. So this is a parallel manipulator. Right? It is not only in this form. You need to identify the kinematic chains, which I will share with you how to look at it and call it whether is it a parallel robot or a serial robot. Right? Sometimes they even have hybrid. They mix these two things together. Okay? So what are the key issues and challenges that you saw in the video? Right? Actually, everything was in the video itself. They were always sharing something. Hey, what about this? Hey, what about that? Then the guy started proposing solutions, right? So what was the first issue that you noticed? Sorry, programming the robot, right? So how did they overcome that? He started showing the robot how to do it, right? Something like playback. Correct? Right? That's one of the issues that they face. So this is the real concerns of why people don't want to adopt robots. So they say, "Oh, I program a robot, oh, so legit." Actually, it's not that legit, right? Just say you need to understand. So for you guys, if you understand this kinematics, it's easier to do the programming. And every robot has a software, has a so-called a syntax. They just follow the program, right? What's the other issue? Of course, but before that, what was the second thing that the guy was worried? Safety, right? Good. So he was worried, hey, the robot comes too close, it whacks him, then how? Right, then what was the solution? Safety fencing or some collision detection sensors, right? So this, if you analyze deeper from a technical perspective, what can be so-called a collision detection sensor? What kind of sensors do you think you can use? Ultrasonic, okay, what else? Touch means, but touch sensor, what is the principle behind it? Touch sensor is basically like a force sensor, right? Maybe we hit something, it detects some force, then it stops if it hits a limit, right? So these are the things you need to translate down to technical components. They may say, okay, I want this feature, but what can you use to help you achieve that? Okay, what other issues that you notice? Sorry? Right, mobility. So what was the proposed solution? Lightweight. So the first robot was rather huge. Second one, when the blue robot came in, was like, wow, very slim, light, you can shift here, shift there. Right? But remember, if you want to shift the robot here and there, you will lose your accuracy. Right? Later on, I will touch about accuracy and repeatability, their differences. So when you have a very mobile robot, you can shift here, shift there, you need to have a good so-called localization kind of a sequence or process. Localization means you want to make sure that, okay, you put your robot here in the virtual model, wherever it is in the controller or whatever, it knows that in the virtual world that is a provisional robot. Because in the virtual world, it will know that my part is somewhere here. Right? So everything is between the controllers, what the controller knows in its virtual world and the real world. There's a lot of offsets that you will get. And you will need to make all this calibration or fine-tuning to make the thing work right. It's not so straightforward, just put the robot there and you start with. Okay? So these are the things I want you to bear in mind, right, for industrial robotics. Now, in the video, you all heard about this robot called Baxter robot. Right? It's a dual-arm, red-colored robot. Right? It's to mimic like a human torso with two hands. Now that is one of the very latest robots that they have in the market. Right? In US, it only costs about 25,000 US. Right? If you compare to industrial robots, these are 1,600K. So you compare to those prices, you get two robot arms, but the payload is very light. Okay, I tell you a very interesting thing. In US, it costs 25K USD. If you want to buy outside of US, it will cost you 100K. Okay. Now, one of the reasons is this. This thing was built by using the American taxpayers' money, the research grant, right? So within America, it's relatively cheap. When it goes out to other countries, they pump up the price. Okay. But then, adoption rate for this is still relatively low because it's very new. Just I think 2 years only. So people are still trying to find out what the capabilities because it's quite light. You cannot carry heavy things. So does it make sense? Especially if you go out of US, okay. Okay? Okay, so for this lecture, we will cover the types of industrial robots, anatomy, and the characteristics of a robot manipulator. We will end off around 11, so we will continue the remaining part in next Wednesday. Okay. Now, industrial robots are mostly large-scale robots. this is generally what you will find in industries. Right? Very typical. You will either see a yellow color robot, orange color robot, white color robot, okay, blue color robot. There is a reason why they have these colors. Okay, if you look at a particular robot and if you are very familiar with the companies, you can roughly tell without looking at the logo where is it from. Okay, if it's blue, usually it's from Yashikawa. Okay, it's the original one. Maybe they never color it. Orange ones, either ABB or KUKA. Right? If it's fully orange, it's from ABB. KUKA has the base actuators all are in black. Right? Yellow ones are usually fun. White ones, okay, white ones, ABB uses them, but sometimes if you want to use in a clean environment, they will tentatively make the robot white. But then sometimes you can find it from Denso robot, so on and so forth. Right? But generally the orange, yellow, blue, you will know. Nowadays, the robot suppliers have become so interesting in their marketing. Because I was in contact with this ABB robot. ABB robot is usually orange color. So they have this customer Cadbury. They wanted to implement robots. So they even offered them, okay, I make your robots, your Cadbury purple color. You know? So they have gotten, their marketing has gone up to actually customize the color as well. But generally people will not bother because, I mean, for SMEs or even MNCs, nobody gives a hoot about your color. So long as the job is done, okay. Typical how robots started being used was car. The automotive industry was one of the ones that widely used industrial robots, okay, in terms of car assembly plant. Right? Now, this thing about arranging your so-called production line into robotic workshop. So you have a whole process line. Maybe the first one does manipulation, second one does drilling, the third one does deburring, so on and so forth. Break down the entire workflow into processes, and you will have one robotic work cell for each process. And then between them, you have some either transfer mechanism or something to bring the part over. Right? So doing this is more like computer integrated manufacturing. They use this term roughly. Okay? Just for your knowledge. Right? If you suddenly hear this word, don't get shocked. Right? And also, the new wave coming in. Do you know what's the current industrial revolution now? The number? Okay, we started off with, we call it industry something 1.0. So we started industry 1.0 when they started mechanization many years ago, decades ago. Right? Then you get some industrial revolution to do a bit of mechanization, not full mechanization, then industry 2.0. When automation came in, there was industry 3.0, very recent one. Now, very recent, I mean, last year, there's this thing called industry 4.0. Okay, industry 4.0 is where your machines will talk to another machine. If something happened to this guy or if this machine has done something, it will communicate with the other machine, hey, I've done this job, you can take over. Right? It's not so flexible yet, but this is the so-called the fourth industrial revolution. Right? So when you hear things like industry 4.0, Internet of Things, these are roughly looking at similar concepts where machine talks to machine. Right? Because if you go onto a factory workflow, there are so many suppliers of these machines. I'm not talking about robotic machines, robotic manipulators only. I'm talking about machines which incorporate robot manipulators. They have other kind of actuators, sensors integrated. And different manufacturer, when they make a machine, it just communicates within itself. Anything go wrong, you will prompt something. But now what they're doing is they're trying to make a machine from one supplier A talk with a machine supplier B, C, D. So they are trying to standardize the communication protocol. they can talk to each other. And that really forms a really automated factory. That means the human is more of a supervisor. Any issue come up, troubleshoot. Right? It kind of increases productivity. Okay? So these are the things that is happening now. So when you go on to the workforce, you will keep hearing all these terms. You will keep hearing IoT, maybe you all have heard already, IoT, Internet of Things, Industry 4.0, but they refer to machine computer, machine in a generic sense. And they make use of cloud computing to store information so that other machines can access the data, so on and so forth. So they just collect data, dump it out into the cloud servers. Then you can communicate. Alright? Okay, some of the typical robot applications that you can have. One of them is more of handling, right? Palletizing, warehousing, loading. You can have pick and place. So let's say for this scenario, if you look at a picture on your right, top right, you see this yellow robot and the white machine here. So the machine probably is a CNC machine. It does the machining of a part. The robot actually transports the parts from this machine to the pallets, for example, or the jigs and fixtures. Right? Probably you may have some other things as well. Just to use a robot arm for this is wasteful. So they may have other applications, but this is one of the things they were using previously. We also have warehousing, loading, unloading, right? They will pack, say, sacks or goonies of stuff with concrete, rice, and then you do palletizing. Okay. They even have this pancake sorting. Maybe I show you this video. Yeah.
ABB Robotics and its strategic partner RG Luma are using robotic technology to transform the production of pancakes. The solution was designed, built and installed by RG Luma to meet Honeytop's own stringent hygienic handling of food, reduced labour costs and improved health and safety levels. Honeytop's pancakes, once cooked, are placed onto a conveyor to help reduce the pancakes to room temperature. Before the pancakes reach the enclosure, a divider pushes the pancakes to either side of the central outfeed conveyor. Then operators manually check the pancakes for consistency. The pancakes are then fed into the robotic enclosure. The enclosure is split into 4 areas of operation and is comprised of 4 flex picker robots, 4 programming and control units, 1 central outfeed conveyor and 2 standard conveyors. The pancakes are then ready to be picked and stacked in selectable stack formations on the central outfeed conveyor. The overall system is capable of stacking in excess of 400 pancakes per minute, offering improved cycle times of 20% and an increased payload of 50%. Complementing the flex pickers is ABB's Pickmaster 3.2 software, which helps monitor progress on the line and enables quick production changes from one product to another. Integrated with the Pickmaster software are 4 gigabit Ethernet cameras mounted in front of each robot and used to locate each pancake's position on the conveyor. The robot then tracks the pancake position for accurate picking and stacking. RG Luma configured the vision software to recognize overlapping products to ensure the flex pickers are able to pick a product overlapped on top of another one. Helping Honeytop reduce its wastage, RG Luma has introduced a new buffer system. It enables the robots to keep pancakes on the buffer shelf until a short stack is identified. The stacks of pancakes are then fed out of the robotic enclosure on the central outfeed conveyor, ready to be packed and distributed. Speaking about the final solution, William Eade, director of Honeytop Specialty Foods Limited, commented, "This is our first investment in robotic automated technology, and despite some apprehension, we have not experienced one issue since the installation over 6 months ago. Turnaround time has been dramatically reduced, and the robots have enabled us to absorb a number of overheads, thanks to reduced labour costs and improved productivity."
amazing, huh? Interesting, right? But you all observe, there are a lot of things to observe from this video. First of all, they all observed that the camera was beside before the robot, right? So the camera was actually capturing the position of the pancakes, feeding that information to the robot controller making decisions which one to pick, right? So your sequence of the camera is very important. You realize, okay, I ask you a question. There was two conveyor, one central conveyor, right? And the central conveyor was the main one that was going on to the packaging, right? You stack two sets of three pancakes. Then the two set conveyors, assuming that when it reaches when it starts and it ends, what about the pancakes that have not been picked up? Do you know what really happens? If you were asked with this decision, what will you do? Makan. Cannot be right, how much pancake you want to eat? I think it's safe. Okay, what happens is this, okay, this thing usually falls down to another conveyor, and this conveyor will bring these pancakes to the start of the first conveyor. Okay, this is what they will do implementation wise. If you notice something else, they also had a buffer system, right? They put some of the pancakes on the buffer system, and then once it realizes that it can pack, then it will use that. And so these are the other things you can use as well. So there are a lot of things that goes in. It's not so straightforward to, okay, I want a pancake sorter, okay, do it. A lot of things you have to counter, a lot of event management or error management you have to worry about. And you have to have provisions to address these issues. Okay? Okay, I think we call it a day for this lecture. We will continue with this lecture, and next week we will start lecture 3 as well. But I want you all to do me a favor, okay? Once I upload the slides, have a read, because lecture 3, 4, 5 I think are very critical one for an exam, and try to so-called familiarize yourself with vectors and matrices. These are the two key mathematics concepts that you will need to use. Okay? Okay, thank you.